Hello Chem 1. Today we're going to take a look at the last two types of chemical reactions, synthesis and combustion. Let's get started. A synthesis or composition reaction is often thought about as the opposite of a decomposition reaction. Remember, decomposition reactions have one reactant, where composition reactions will have one product. And it's usually only two things coming together to form that one product. So if we look at our model down here, A plus B equals AB. Most of the compositions you're going to see are simple compositions where you just have two elements combining to form a compound. So if we look down here at the bottom, we have strontium solid and chlorine gas, which is diatomic. And when they come together, we're going to take strontium as a cation and chlorine as an anion. Strontium is a +2, chlorine is a -1. So when they come together, they will be SrCl2. Since no water is present, that'll more than likely be a solid. We also have complex compositions or complex synthesis reactions, and those are just the opposite of the models for decomp that you have on your equation sheet. The easiest way to recognize these reactions is if both reactants have the same element present. So for instance, if we have calcium oxide, calcium's a +2, oxygen's a -2, so this would be CaO, and that's a solid. Placed in a tube with carbon dioxide gas, CO2, gas. Notice we have oxygen in both of these reactants. That should immediately get us to think, this is a reverse decomp. I got to figure out which decomp model this is. And if you look, you'll see that when we decompose a metallic carbonate, we get a metal oxide and carbon dioxide, which means this is going back to a metallic carbonate. So CaCO3, which is carbonate. Anytime you have two reactants and the same elements present in both those reactants, look at your decomp list and write it backwards. The last type of reaction we're going to talk about is combustion reactions. There's common combustion and uncommon combustion. Common combustion reactions typically are going to burn a hydrocarbon. A hydrocarbon is simply a hydrogen and carbon bonded together in different ratios. Some of these you're familiar with. For instance, propane you might use in your gas grill. Butane is a type of gas we can also burn. Octane is in gasoline. But you can see they're just different ratios of carbon to hydrogen. When we burn a hydrocarbon, we're always going to need oxygen gas present. If you look at the model here, XY would represent the hydrocarbon combined with oxygen, and then we get the one element combining with oxygen, and then the other element combining with oxygen. When you burn a hydrocarbon, the two oxygen-based products you produce are carbon dioxide and water. So if you ever have to predict the products of burning a hydrocarbon, carbon dioxide and water is what you're going to produce. So down here it says butane is burned in air. That word burn, you should immediately recognize this as a combustion reaction. Butane is C4H10, and that's a gas. And you're burning it in air. That means O2 is necessary. And we immediately know that this carbon is going to combine with oxygen, so CO2, and that'll be a gas. And then this hydrogen will combine with oxygen, and H2O is the most common thing that will be produced there. And that'll also be a gas. Here's another example of methane being burned in oxygen, and we also have CO2 and H2O being produced. An uncommon type of combustion is when we have something that will burn in oxygen. They could form an ionic oxide or a covalent dioxide. So if we have calcium sulfide, and it's solid, and we burn it in air, so it's going to combine with O2. We're going to take this calcium and combine it with oxygen. Calcium is a +2 as a cation, so this will produce calcium oxide. And then the sulfur will combine with the O2 and form a dioxide since that's covalent, SO2. This type of combustion isn't very common, but we do want to make you aware of them. All right. After today, you should be able to do synthesis and combustion reactions and predict products for both. Keep practicing all these types of equations and let me know if you have questions. We'll see you soon.